Okay, triangle congruency by angle side angle and angle angle side. So two new ways to prove congruency in section 4.3. All right, the angle side angle postulate says if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two angle or triangles are congruent. So what does that mean? So again, I've got two triangles, A, B, C, that we want to prove congruent. That doesn't look very congruent. D, E, F. And if we can show the two angles and the included side, so two angles, A and B, and the included side of one triangle are congruent to two angles and the included side, in other words, the side between the angles, then we can say that the triangles are also congruent. So let's use this in a proof. So if I have a couple of triangles, and I'm going to call this one CAB, and then I've got another one, and that's going to be DEF. And I know that these are right angles, and I am told that A is congruent to D, and that AB is congruent to DE, and I'm told that angle B and angle E are right angles. I want to prove that triangle ABC is congruent to triangle DEF. So step one in my proof is to list my givens. Angle A is congruent. I don't know why this is being so difficult today. Angle A is congruent to angle D. AB is congruent to DE, and angle B and angle E are right angles. I'm sorry, this is not working very well today. These are all given. Okay? So the second thing I need to show is that I've got B and E congruent. And can I say that angle B is congruent to angle D? And what would the reason be? So we did have a theorem or a postulate, I can't remember which, that said all right angles are congruent. So now I can say that triangle ABC is congruent to triangle DEF by, I'm sorry, that keeps popping up, by my angle side angle theorem. Okay? And notice also that, remember that when we show congruency, we make sure we do it in the right order. Angle A starts this triangle and angle D starts that one. Then I go to my right angles B and E and then to C and F. I cannot say that triangle ABC is congruent to FED. We've got to go in the same order when we list our angles. Okay? So our next theorem is the angle side theorem. And this one says if two angles and a non-included side, so not the side between them, of one triangle are congruent to two angles in the corresponding non-included side of the other triangle, then the triangles are congruent. So again, I've got A, B, C, and I'm going to do D, E, F. So two angles and a non-included side. So A, B, and line BC, oops, I have to do that, are congruent to D, E, and side EF. So A and D are congruent, B and E are congruent, and BC is congruent to EF. So that's another way to show congruency. So let's do one more proof. Nope, I didn't write it out. Okay, so here's our diagram. So our diagram shows, it's going to look like this, and I'm going to use W, M, R, and K. And I'm going to draw a line through the middle, and we are going to say that angle M, and I'm going to list these as my givens. Angle M is congruent to angle K. I am also told that MW is parallel to KR. Okay, and I want to prove that triangle MRW is congruent to triangle KWR. So take a look and find those two triangles on the diagram, and let's continue with our proof. So the reason for those two is that they are given. So I still need, I've got an angle and an angle here. I don't have any sides. I have two sides as parallel, and I need another angle. So the fact that these two sides are parallel, and the fact that M or WR acts as a transversal, I now am going to be able to say that these two angles are congruent. So angle MWR is congruent to angle KRW, and my reason for that is alternate interior angles theorem. So now I've got angle, angle, and I should make that a double so that I can distinguish between my two sets of congruent angles. I need a side the same. Well, I can say that WR is congruent to WR, and that's by the reflexive property of congruency. So I've said that this side equals itself. Since that side is in both triangles, and so in the bottom triangle, let's switch colors, I've got, goodness, it's jumping around today. I've got side, angle, angle for this triangle. And in my top triangle, I also have a side and an angle and an angle. So for step 4, I can now say that triangle MRW is congruent with triangle KWR by angle, angle, side. Okay, so just two more ways to show congruency of a triangle, and that's it for today.